Hey everyone, I welcome you all to another video. In this video, we are going to start with the effective stress and permeability of soil. Now, if you see this question, they have given that non-homogeneous soil deposit. Non-homogeneous soil deposit consists of a silt layer, which is sandwiched between fine sand layer at top and clay layer below. So, we'll draw the diagram for the question. Sorry. So, in the middle, silt layer, which is sandwiched between sand layer and clay layer. We'll take the depths as Z1, Z2 and Z3. Also permeability as K1, K2 and K3. Now we'll write down the given condition. They have given that the permeability of silt layer K2 is 10 times the permeability of clay layer 10 K3 and 1/10 of sand layer. So 1/10 of K1 and they have given the thickness of silt layer is equal to 2 times thickness of the sand layer 2 Z1 and 2/3 thickness of the clay layer. The equation for average permeability KH equal to K1 Z1 plus K2 Z2 plus K3 Z3 divided by Z1 plus Z2 plus Z3. Now K1 is equal to 10 K2. We'll take all the terms with respect to K2 and all the terms with respect to Z2. So Z1 which will be equal to Z2 by 2 plus K2 Z2 plus K3 will be equal to K2 by 10. Z3 will be equal to 3 by 2 Z2 divided by Z1 Z2 by 2 plus Z2 plus 3 by 2 Z2. Now take out the K2 Z2 as common. So we'll get 10 by 2 plus 1 plus 3 by 20 divided by down we'll take Z2 as common 1 by 2 plus 1 plus 3 by 2. We can cancel Z2 and Z2 here. So K2 into 100 by 20 plus 20 by 20 plus 3 by 20 divided by 1 by 2 plus 2 by 2 plus 3 by 2, where we'll get K2 123 by 20 divided by 6 by 2. K2 into 123 by 20 into 2 by 6, where you will be getting 123 K2 divided by 60, which is KH. Now the formula for average vertical permeability will be equal to Z1 plus Z2 plus Z3 divided by Z1 by K1 plus Z2 by K2 plus Z3 by K3. So Z1 will be Z2 by 2 plus Z2 plus Z3 will be, we'll see what is Z3. Z3 is 3 by 2 Z2 divided by Z2 by 2. K1 will be equal to K1, which is 10K2. 10K2 plus Z2 by K2 plus Z3 will be 3 by 2 Z2 divided by K3 will be K2 by 10. So if we take Z2 as common here, 1 by 2 plus 1 plus 3 by 2. And if we take, before taking Z2 and K2 in common, we'll normalize the denominator, which is Z2 by 2 into 10K2 plus Z2 by K2 plus 3 by 2 Z2 into 10 by K2, where Z2 will be 6 by 2 divided by, down will take Z2 and K2 as common, Z2 by K2. So 1 by 20 plus 1 plus 30 by 2. Again, Z2, Z2 will get cancelled. So we'll be leaving with K2 into 3 divided by 1 by 20 plus 20 by 20 plus 300 by 20. 3K2 divided by 321 by 20, which will be 3K2 into 20 by 321, where we'll get 60K2 divided by 321. Now for calculating the ratio of horizontal permeability with respect to vertical permeability, KH by KV equal to, so we got KH as 123K2 by 60. 123K2 by 60 and KV as 60K2 by 321. So it will be equal to 123 by 60. We can also calculate cancel K2 K2 here into 321 divided by 60. 123 into 321 divided by 60 into 60, which gives 10.9675 is the right answer. They have asked us to find out the value of effective stress at plane XX. If you see the diagram, I have drawn a piezometer at XX and the head loss at from top it is denoted by HX. Now they have given gamma sat is equal to 18 kilonewton per meter cube and gamma W equal to 9.81 per kilonewton per meter cube. Okay. First, we need to find out the value of Hx. So to calculate value of Hx, we need to find out the head loss from A to B. From the diagram, if you see that the head loss from A to B is 3 meters. So with this we can calculate the hydraulic gradient. I is equal to H by L, where L is length of soil specimen, because um, from A to B the flow is happening. From A to B flow is happening. So you should take length of specimen as 6. Okay. So I will be equal to 3 by 6, which is 0.5. With this we can calculate Hx. So Hx is equal to I into length of x, which will be 0.5 into length of x is equal to 5, which is 2.5 meter. Now they have asked us to find out the effective stress. So effective stress is equal to total stress minus pore water pressure. They've asked us to find out the effective stress at x. Therefore, total stress at x will be equal to. So if you see at x soil sample, you have above soil sample there is water table which is 4 meter above the soil specimen. So total stress will be equal to 4 gamma w plus length of soil sample until x will be 5. 5 into gamma saturated. And if you see the pore water pressure, Ux is equal to, pore water pressure will be calculated by 4 minus, no, it is not 4. Actually, yes, you have to minus the Hx. So pore water pressure will be equal to gamma W into, if you see the total datum height till soil sample at x will be equal to 3 plus 1 plus 5. So water table is away at a distance of hx. So minus hx equal to gamma w 9 minus hx. Sigma x dash will be equal to 4 gamma w 5 plus 5 gamma sat minus 9 gamma w plus hx gamma w. 5 gamma sat minus 5 gamma w plus hx gamma w. Therefore, sigma x will be equal to 5 into gamma sat minus gamma w plus hx gamma w. We can say gamma sat minus gamma w equal to gamma submerged. 5 into 18 minus 9.81 plus hx will be 2.5 into 9.81. Now we'll calculate the solution. 18 minus 9.81 into 5 40.95 plus 2.5 into 9.81, 24.525. Therefore, effective stress at X will be equal to 24.925 plus 40.95, which is 65.475 kilonewton per meter cube. If you see this question, you might be thinking that the flow is parallel to the bed plane. But if you see the water table at point A, just a minute, at point A it is, we'll name it as point A. Point A is 15 meter and point B it is 10 meter. So the flow is vertical. Now, if we take out the permeability, average permeability of vertical flow, it is given by K average will be equal to sigma Z divided by sigma Z by K. So for K1, Z1 is equal to 20 plus for K2, Z2 is equal to 10 plus 20. For K3, Z3 is equal to 10 divided by 20 by K1 is 2 plus 30 by K2 is 3 plus 10 by K3 is equal to 1, which will be equal to 20 plus 30 plus 10, 60 divided by. So if you take the LCM of the down one, it will be 6. So 60 by 6 plus 60 by 6 plus 60 by 6. 60 divided by 10 plus 10 plus 10, which will be equal to 2 meter per day. Now they have asked us to find out the seepage discharge. So seepage discharge Q is equal to K I A. So I will be nothing but H by L. H is head loss by length. Head loss will be equal to 15 minus 10 divided by total length will be 20 plus 10 plus 20 plus 10, which is 5 by 60. So QS is equal to 2 into 5 by 60 into, if you see PQ, if you see the area PQ, length it is 3 meter. So we will be calculating for unit width. So we should be taking as 3 into 1, which will be equal to 3 cancelled by 2. Sorry, here it is 60, na? 20, 10, 5 by 10, day per meter, which will be equal to 1 by 2 day per meter. In this question, let us write down the given data. Given. So they have given the area of the soil sample as 80 centimeter square, which is 80 into 10 to the power 2 mm square. And they have given us the coefficient of permeability of soil 1, that is K1 is equal to 0.2 mm per second, and they have asked us to find out the K2. If you see the question, they have given the flow rate of the soil indirectly, that is over a period of 15 minutes 200 ml of water was absorbed, means discharge rate Q is equal to 200 divided by 15, which is the seepage discharge. 15 minutes, so we have to take it as seconds, so 200 by 15 into 60. And as per Darcy's law, discharge rate will be equal to KIA. So if you see the diagram, there is a head loss of water from point P to Q. Therefore, flow is perpendicular to bedding plane. So K average will be equal to sigma z by K. So Z1 will be equal to 150 mm plus 150 mm divided by Z1 by K1, 150 divided by 0.02 plus 150 divided by K. To calculate I will be equal to head loss by length of soil specimen. So head loss will be equal to 600 divided minus 300 divided by 150 plus 150. If you see the diagram, you can get the data. That is equal to 1. Now Q is equal to 300 divided by 150 by 0.02 plus 150 by K into 1 into 80 into 10 power 2, which will be equal to the value of Q is 200 divided by 15 into 60. Since they have given the flow as ml, if you change it as mm cube, so ml 1 ml will be equal to 1000 mm cube, which will be 200 into 10 to the power 3 divided by 15 into 60. 200 into 10 to the power 3. Solving the above equation, K will be equal to 0.045 mm per second. From this question, we can know that the clay is in a submerged condition. clay is in submerged condition. They have given the unit weight of water as 10 kilonewton per meter cube. Solution. They have asked us to find out the factor of safety against sand boiling. So factor of safety will be equal to submerged pressure divided by seepage pressure, because here water is flowing in the soil. So the pressure acting in the clay will be submerged pressure, and the pressure given by the water will be seepage pressure. So submerged pressure will be equal to Z gamma submerged gamma dash divided by seepage pressure will be equal to Z gamma W. So if we see this, the value of Z will be equal to 10. Factor of safety will be equal to 10 gamma dash divided by water table has come down from 20 to 10 meter. So 10 gamma W. Gamma sat gamma dash is equal to gamma sat minus gamma W. They have given us the saturated weight of clay. Since clay is in a seepage condition, the unit weight will be saturated unit weight. So gamma dash is equal to 20 minus 10, which will be 10. So factor of safety will be 10 into 10 divided by 10 into 10, which will be equal to 1.